So here is the highly anticipated, I hope, solution to this tricky suds question. If you couldn't solve the question, you might want to consider um, going over my series on suds. If you lack the skills required to solve this, rationalizing suds, simplifying suds, um, addition and subtraction of suds, so on. So let's obviously multiplication of suds as well. But let's get into it. So there are two ways to solve it. I'm going to go to the long way first, which is the way that I would expect most people to do it. This is the way I first solved it. So, um, the first term of this summation, reading 1 over root 1 plus root 2. So obviously the square root of 1, we assume that to be positive, so it will be 1 over 1 plus root 2. And from there, we times it by 1 minus root 2 over 1 minus root 2. And we end up getting 1 minus root 2 over minus 1. And so we do the second term, the same thing with the second term. We're end up getting root 2 minus root 3 over minus 1. So obviously 2 minus 3 is minus 1. And so there's a pattern. Let's just go back to the first one. We have root 1, root 2, root 3, root 2, root 3, root 3, root 4. So after rationalizing each one, we should begin to notice that it starts cancelling out. So the largest third on the first fraction and the largest third and the smallest third on the second fraction are the same, and they end up cancelling out. And then this repeats for the second and third, and the third and fourth, and so on. And so basically every other third except the first and last one cancels out. So you can see here 1 minus root 2 plus root 2 minus root 3. So this is negative, this is positive, and then on the next one will be plus root 3 minus root 4, and then the root 3 will cancel out, and so on and so forth until the last term. And because the last term is the largest one, so we know that the largest one here, if we were just to take this as a microcosm of the whole summation, the root 3 remains after, so this one, the root 1, which is 1, and the root 3 remains after this. So as we know that this one and this one and this one and this one are cancelled out, because there's no corresponding surd for this, it stays at the end with the 1 at the start. Here, and they're all over minus 1 because of the difference of 1 between the two numbers under the side. And then you end up getting 1 minus 4 over minus 1 because root 16 minus 4. So all of the roots are assumed to be positive in this question. And then we've got minus 3 over minus 1 to get 3. So that's what's the long way. And here is the 4-line solution. It's a bit tricky to get this first time, so well done if you have. So you have the general form of the sequence 1 over root n plus n plus 1. So if n is 1 here, we have 1 and 2, n plus 1, 1 plus 1 is 2. And then we have root n minus, we're times it by root n minus n plus 1, as you would know if you watched my video on rationalization.